or y values. Okay. All right. So again, if A is greater than 0, we're falling above our asymptote. So, oh, I hate when it does this. So our graph might, if this is our asymptote, we might be above. If A is less than 0, if this is our asymptote, then we're maybe coming from underneath. If our base B is between 0 and 1, we have a decay. Greater than 1, we have a growth. Okay, and we look at K to be our asymptote. That's where we're going to be approaching, but we never cross. Oh, you do. You look at your B. Well, what does this look like? A decay. This one, what does this look like? If you would flip this back up over, just reflect it over your asymptote, what is this one going to be? A decay. Maggie, does that make sense? Okay. All right, graph the following. Ask yourself the following question. Is it a growth or a decay? Are you above or below the asymptote? All right, so if I don't have a value out to the side, put 0. Okay. Your values for x. X is up in the exponent. The exponent can be any value. It can be positive, it can be negative. So our domain is always a set of reals. There is nothing that x cannot be. Okay? All right, is this a growth or a decay? We know because of the 2, we have a growth because it is greater than, your b is greater than 1, correct? And are we above the asymptote or below the asymptote? In other words, what's the sign right here? Is there a positive sign or a negative sign? So are we above or below? We are above the asymptote. And where is my asymptote? Yep. So your asymptote is at 0. So our domain or our range would be y is, we know that this is a growth. Let's figure out what let's do a little bit of graphing. We know that our asymptote is at 0. So you need to make sure that you're dotting that in very clearly. Do a little XY chart to help you here. All right? Use negative values, positive values, and 0. So if x is negative 1, I'm going to have 2 to the negative second. Would you agree? Which is 1/4. So at negative 1, we're at 1/4. At 0, we're going to be at what? 1/2. And at 1, we're at, so this is coming from the asymptote and going up. It's a growth. It's getting increasingly larger, correct? Huh? At 1, you're at 1. So what is our range going to be? It is not. Look at your y-axis. We are coming down and we're always staying above our asymptote. It's greater than 0. Not equal to, you'll never hit that asymptote. You'll never cross that asymptote. You're always staying above the asymptote. That's it. It's greater than 0. So x will always be the element of the reals. Your range, you will determine whether or not you're above or below. So if you're above, you're greater than. If you're below, you are less than, right? All right, here we go. Is this a growth or a decay? We have a decay. Are we above or below? Are we above or below? Look at the 3. Above or below? Below. It's negative. You're looking at the sign, positive or negative. So is it above or below? Below the asymptote. Where's the asymptote? At 1. There's your asymptote. Okay? So first thing you do is at 1, draw your little asymptote. Okay, what's my domain? X is an element of the reals. What do you think your range is going to be? Yep, because if we are below, we will be less than. Now we do a little XY chart to help us. We use a negative value like -1, a positive value, and 0. So at -1, what does this exponent become? 0. What's 1/3 to the 0? What's 1 times -3? What's -3 plus 1? So at -1, we're at -2. At 0. At 0, my exponent becomes what? 1. 1/3 to the first is 1/3. 1/3 times -3 is? And -1 plus 1 is? Okay. At 1, we get 1/9, correct? So we really get -1/3 plus 1 is 1 1/3? No. So you get -3 times 1/9 plus 1. That's -1/3 plus 1, so 2/3. So this doesn't look real smooth, but that's what it should look like. Remember, flip it up over the asymptote. Doesn't that look like a decay? You reflect it, just kind of flip it up, and doesn't it look like it's coming down? All right, are we good? No, the y value will never be at 1, but I can use any x value because my domain is a set of reals. You got it? Maggie? Okay. All right, so here we go. Growth or a decay? Because of the above or below? Because of the +4. Asymptote? -3. Domain? Okay, range, y is greater than -3. I wrote the wrong thing. All right, you graph it. I need to see this asymptote on your paper, okay? You've got to show it to me. Oops, I did something wrong. Oh. This should have been a growth, shouldn't it have? We said it was a growth. We're above. But why did we get a decay? Why do you think? Mm-hmm. So you have to be careful. No, it's still, well, it graphs as a decay. It's said to be a growth, though, because you're looking at the sign of the 4. No, I would call that still a decay, but you would want to, you just need to make sure that you're keeping in track of whether or not this is positive or negative. Go by what the graph says. Okay, but in your mind, kind of have an idea of what it should look like. And if you get something funny, like I just did, I had to reevaluate. Why did I get that value? Well, it's because of the negative sign on my exponent. Okay. All right, so what makes this problem different than the next one? There's no equal sign. It's an inequality, correct? So we're still going to think about it in the same way. All right, we're still going to look at the information in the same way, but we've got shading now. There's not just a line that we're looking at, and we need to decide if our line should be solid or dotted. What should our exponential line be in this case? Because of the lack of a equality sign. All right, so we're going to say that x is an element of the reals. Y, is that going to be greater than or less than -4? Okay. 1, 2, 3, 4, dotted line. All right, do our little XY chart. At -1, I'm going to get -4.5, yes? No, I'm going to get -3.5. So at -1, I'm at -3.5. At 0, I'm going to be at -3. I'm just plugging it in, Emma. And at 1, I'm going to get -2. So we said this is dotted. And so, will I be above or below that line? Below. I'm going to shade less than. I want less than, so this is what you need to show. My shading can. My shading can. My graph will never cross the asymptote. Does that make sense? Okay. All right, here we go. What is my domain? X is an element of the reals. That's what this one always is. Always, always, and forever. These are always reals for the domain. What's your range? Y is greater than 1. Do we want a solid or a dotted? Okay. So at 1, we do our dotted asymptote. Our little XY. This should be a what? This should be a decay. And the X is positive, right? So it shouldn't flip it. Does that make sense? Okay. So at -1, I'm going to get 3. At 0, I'm going to get 2. And at 1, I'm going to get 1.5. So at -1, I get 3. At 0, I get 2. And at 1, I get 1.5. This is solid. Am I shading above or below? -1, 3. All right, so then we talked last year about your growth and decay equations. You need to memorize these. All right, they should be somewhere stuck in the back of your head from last year because you had all of this stuff. And compound interest. Okay. So remember, let's think about this. If n sub naught is our beginning amount, how much we start with, r is our rate, but do we ever write a rate in the percent form? We always want our rate as a decimal, okay? Make sure you do a decimal. T represents our time. If I have 1 plus r as my growth rate, is that a growth or a decay function? It's a growth, right? If I want decay, then I'm going to do 1 minus r represents your decay because you're getting your base to be less than 1. Does that make sense? Are we good? Do you remember this? All right. If we do compound interest, that's used in banks, how your money is compounded. So this is your beginning amount. R is still your rate. T is still your time. Now be careful. N appears in two spots. And it's how it's compounded. If it's compounded semi-annually, then what is that going to represent? What value would I do for semi-annually? 2. If I said monthly, then my N would be 12. If I did annually, what would I have? 1, okay, correct? If I did daily, what would I have? 365. 366. On an average year, it's 365. All right? All right, so business owners keep track of the value of their assets for tax purposes. Suppose the value of a computer depreciates, so is that a growth or a decay? Okay, at a rate of 25%. What's my rate going to be then? Am I going to use in my problem? 0.25. Remember, you're moving your decimal point 2 places to the left. Determine the value of the laptop. 2 years, therefore my time is after it's been purchased, which says my beginning amount is 3750. So which of the what formula am I going to use if I want a decay? So I'm going to say I'm going to say my amount, which is 3750. And I'm going to go 1 plus or minus 0.25. Do I have to divide that by an N? Because I don't have the word compounded in there. It's just a normal depreciation. What's my time going to be? 2. So this is 3750.75 squared. All right, what do we got? Work it out on your calculator. $2,109 and so make sure you can do this on your calculator, that we're all getting the same answer. Because sometimes it's computer error or person error, not calculator error. That's how you're putting it in. Okay. We all get it? Okay. All right, so then here, in 1990, the U.S. Census state population of LA County was 8,863,000 and a few people. By 97, the population increased to 9,000 and a bunch of people. Find the yearly growth rate by dividing the difference. What was I saying? The difference by the population of 1990. So what's the difference? Because that's my growth rate. What is the difference divided by the amount in 1990? So we're going to subtract, right? Oh. So 9145219 minus 8863. Oh. So I got 282167. 282167 divided by, what is that? by 8863052, correct? Divided by 8863052. And what is that? So we'll do 0.032. Let's carry it out a couple. All right. Now, this is a growth rate. This is my growth rate. Is that an increase or a decrease? So what I'm going to say, assuming the same growth rate, predict the number of people who will be living in 2010. So what is my time? 10 years, because we're taking it with respect to 1990, right? 12. Okay. My rate is 0.032, so I'm going to say, how many did I start with? 8863052, 1 plus 0.032, correct? To the 20th. You got a lot of people. I got 1, 6, 5, 8, 8, 2, 1, 0. Now, can I have 0.96 people? You didn't get that number? Hold on. So 1.032 to the 20th, right? Times 8863052. I got 16. Oh, that's not what I got. I got 166 40916. Is that right? And have we increased? Yeah, we almost doubled it, didn't we? Can you have 0.96 of a person? Not the last time I checked. You can have 0.96 cents, but not 0.96 people. You could. You could talk about a lot of pregnant people, but. All right, are we good?